Today we're starting Unit 3, Functions Part 3. It'll be our last unit over Algebra 2 review. I'm going to focus on quadratics today. So then on the next piece of paper, you're going to see two different forms of a quadratic. We have the vertex form and we have the standard form. When you're writing your vertex form of a quadratic, your stretch is your A and it's written out front. The opposite of the x for the vertex goes in the parentheses. And then we're going to square it because it's a quadratic, and whatever the k is, you're going to either add or subtract from the back. For standard form of an equation, the ax squared comes first, your b term is the middle term, and it's always going to have the x, and then your c is your constant. To find the vertex when something's in standard form, you're going to use this formula. You're going to take the opposite of the b and divide it by 2 times the a, and that's going to give you your x coordinate. To get your y coordinate, you're going to take the answer that you just got right here, and you're simply going to plug it in for where the x's go. And this will make more sense when we do an example in just a little bit. A couple other little things I want to remind you of from Algebra 2. If your a on either of these equations is greater than 0, which means it's positive, your parabola is going to open up. And if your a on either one of these equations is negative, less than 0, it means it's going to open down. If I ask you to find an x or a y intercept from a picture, you simply just write down the points of where it crosses the x and where it crosses the y. If I ask you to find the x and the y intercepts from an equation, then you're going to have to go do some algebra. To find the x-intercept, you're going to let y equal 0 and solve. This will usually involve factoring. To find your y-intercept, you're going to let x equal 0 and solve. So we're going to do 2 examples. So if you're at home doing this right now, you need to go ahead and pause the video, copy down the information that I just gave you so you can have it in your notes because you are going to have an open note quiz next week. Okay, so here's example 1. On example 1, I'm giving you a picture of a parabola, and I want you to be able to answer all of these questions that go with it. So the first question I'm asking you is just, what is the vertex? We're going to remember the vertex is always in the middle of the parabola, so it's right here, and that ordered pair is -2, -1. When I ask you to write the axis of symmetry, the axis of symmetry is the vertical line that passes right through the vertex. Because it's the axis of symmetry and it's vertical, it's going to be x equals, and x at the vertex is -2. When they ask me for the intercepts of a picture, I simply go look at where it touches either axis. So it touches the x at -3, 0, at -1, 0, and then it also touches the y at 0, 3. So when I ask you for the intercepts, I want anywhere it touches the x or the y. When they ask you about the intervals of increase and decrease, we're going to remember that when they ask you about intervals, they're asking about the x's. So they want to know on this parabola, as I go from left to right, where does it increase? Well, I hope we can all agree if I start from left to right and I go to the vertex, I'm decreasing. And then once I turn after the vertex, that's when I start to increase. So my turn happens right here at -2, so parentheses because it's a turn, off to infinity. So my parabola is going to increase between the interval of x being greater than -2 off to infinity. And I hope we can agree as we go from left to right that I'm decreasing until I get to the vertex. So from -infinity to -2 on this side. The next question wants me to write the equation in vertex form. We practiced this a minute ago. We've got y equals. Remember, A is your stretch. This opens up, so it's going to be positive. From the vertex, I went right 1 and up 1, which means there is no stretch, so my A is equal to 1. Because I went left 2 inside here, I'm going to have a +2, because we always do the opposite. Because I went down 1, I'm going to have a -1. So I take whatever the vertex is, and I put the opposite in for the x, and then I bring down the y. When they ask you to take an equation from vertex form to standard form, all we're going to do is get rid of the parentheses. So I'm going to go rewrite this. Instead of writing x plus 2 squared, I'm going to write x plus 2 times x plus 2, and then I'm going to bring down my -1. From here, we're going to FOIL. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And then again, I have to remember to bring down that minus 1. Now I'm simply going to collect like terms. And 4 minus 1 is 3. Okay, so that's the first example. So from a graph, you should be able to tell me the vertex and axis of symmetry, all the intercepts, the interval of increase, decrease, vertex form of an equation, and standard form. What we're going to do now is I'm going to give you something in standard form, and we're going to also go through and answer some questions and graph. So the first thing we're going to notice about this equation is it starts off with a positive x squared. Because it starts off with a positive x squared, it's going to open up. I know that a is a number in front of x squared, so a is 1. B is my middle term, which is negative 4. And c is my constant, which is negative 5. In order to find the vertex, I have to use this formula over here. To find the x coordinate of the vertex, the formula says take the opposite of b and divide it by 2 times a. The opposite of negative 4 is positive 4, divided by 2 times 1, because 1 is a. 2 times 1 is 2, and 4 divided by 2 is 2. So the x coordinate is 2. To find the y coordinate of the vertex, this formula says that I'm going to take the function value of what I got for x. What that really means is you're going to take this answer that we just got for x, and we're going to plug it in right there. So everywhere there's an x, I'm going to put 2. So instead of putting x squared, I'm going to have 2 squared, minus 4 times 2, minus 5. And then we're just going to go evaluate. 2 squared is 4. 4 times 2 is 8. I'm going to bring down the 5. 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. So my y value is negative 9. And this is all for the vertex. Okay, so now I can actually go graph that. I can go graph the point 2, negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertex. And I know that it's going to open up. I'm not going to graph it yet, because first thing I'm going to do before I graph it is I'm going to find my intercepts. The next question they asked me is for the axis of symmetry. Remember, it's going to be a vertical line that passes right through the vertex. Vertical lines always start with x equals, and it's always going to be x at the vertex. So the equation is x equals 2. Now we're going to go find our intercepts. When you don't have a picture and you're looking for your intercepts, we're going to use algebra. So find the x-intercept. You're going to let y equal 0 and solve. So right up here, we're going to let this equation right here, x squared minus 4x minus 5 equals 0. Because I have a quadratic with 3 terms, I'm going to factor. This happens to be a 1x squared, so it's easy to factor. When you have a 1x squared, I know that x times x is x squared, so these both have to be an x. When you have a 1x squared, you look at your last number, which is negative 5, and you go list all your factors of negative 5. So negative 1 times 5 and negative 5 times 1. One of these factors is going to add to the middle. So negative 1 plus 5 adds to positive 4. I want negative 4. But negative 5 plus 1, that adds to negative 4. So these are the two that I'm going to pick. Negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. Once you have your factors, you set them equal to 0 and solve. So my first equation is going to tell me that I have an x-intercept at 5 and a y-intercept at negative 1. So I can go over here to my graph. So I'm going to have an x-intercept at negative 1 and at 5. So I can also go write those up here. Negative 1, 0, and 5, 0. I still have to go find my y-intercept. So this was the x. Now I'm going to go find the y-intercept. When you find the y-intercept, we let x equal 0 and solve. So go back to my original equation, and everywhere there's an x in these two spots, I'm going to go put zeros. So y equals 0 squared minus 4 times 0 minus 5. 0 squared is 0. 4 times 0 is 0. 0 minus 5 is negative 5. So my y-intercept is at 0, negative 5. Okay, and now I can go ahead and draw up my parabola. Hopefully yours looks better than mine. And the last thing we have to do is do the intervals of increase and decrease again. Remember a second ago, I reminded you that intervals are your x values. So I want to know where on this parabola are we going up, are we increasing? So hopefully you can say from the vertex to the right is where I'm going up. So that would be from 2 to infinity, I'd be increasing. And the left side of the graph, from negative infinity to 2, is where my graph is decreasing from left to right. So those were the notes that we took in class today. And then I passed out a homework assignment. On your homework assignment, you needed to have it due by Wednesday. It was worksheet 3-1. This is what 3-1 looks like. And it's due Wednesday. Okay, so bring questions to class, and I'll go over any questions that you have. And remember, one more time, this is due Wednesday. Go to Google Classroom to submit your answers. Hope that helped for those of y'all that were absent